Greetings, boys and girls. In tonight's video, we're going to be discussing how to convert improper fractions to mixed numbers. Now remember, improper fractions are simply fractions that are greater than one whole. So if a fraction is greater than one whole, we can definitely represent it as a mixed number because we can take a whole out and we may or may not still have a fractional part left over. So let's look at the first picture that you also have on your homework sheet. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fourths represented. So now that I see I have 10 fourths, I'm trying to see how many wholes can I pull out of 10 fourths, or how many wholes can I make? So I'm going to shade in until I see what I have. All right, so I'm shading in 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths, 10 fourths. So now look, I had 2 wholes, so that would represent 2 and then I have 2 fourths represented. So I can say 2 and 2 fourths. I could also say 2 and a half, but for the sake of this illustration, we see that we have 2 and 2 fourths. Now we have another problem that's very similar. This time I have 1, 2, 3, 4, 5, 6, 7, 8 pieces that are cut in the size of thirds. So I have 8 thirds. So I'm going to draw a couple of not so perfect circles, and I'm going to see how many circles I can completely fill with the 8 thirds. Okay, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7 thirds, and then 8 thirds. So look, I was able to fill 2 circles all the way in. Therefore, I have 2 wholes and 2 thirds. Please make sure you take a moment and you fill in your 2 images on your paper. Remember, if I move too fast, please pause the video. Now we're going to actually look at how can we convert improper fractions to mixed numbers without having to draw a picture. Because sometimes we're going to have really, really large numerators and we don't want to have to, draw pictures like that, or our denominator might be a larger number. So there are a few steps that we can do when we convert improper fractions to a mixed number. The first thing is to set up a division problem. Okay, and we want to put our numerator inside the bracket, that will be our dividend, and we want to put our denominator on the outside of our division bracket. And so what's going to happen is the result, our quotient, is going to be the number of wholes that we have. If there is any remainder, that will be our new numerator, and then our denominator is going to stay the same. When we convert from improper fractions to mixed numbers, our denominator stays the same. And guess what? When we convert from mixed numbers to improper fractions, our denominator still stays the same. The reason for this is because we are still talking about the same sized pieces. The size of our pieces aren't changing. What is changing is we're grouping wholes. We're seeing how many wholes we can pull out, or when we convert in tomorrow's homework, we're going to just see how many individual pieces we have in all. So let's put this into use. Okay, let's practice this. So I have 12 sevenths, and I want to convert that to a mixed number. So what I want to do is the 12 my numerator, goes on the inside of my bracket, and my 7 goes on the outside. So now I'm asking myself, how many times does 7 go into 12? Well, it goes in just one time, and I would put a 7 underneath the 12. 12 minus 7 would be 5. So this 5 becomes the remainder. Okay? Alrighty. So now, remember what I said. My quotient, not including the remainder, that is my whole number. So now I have 1 and something. My remainder becomes my new numerator. And the best part is my denominator stays the same. You see it was a 7 over here. It is still a 7. Okay? So my final answer would be 1 and 5/7. I'm going to give you a moment to jot that down. Please make sure you show your work. Okay, moving on to the next problem. Now we have 39/8. Now remember, I'm going to set this up as a division problem to be able to convert it. So my 8 goes on the outside of my bracket, 39 goes on the inside of my bracket, and I'm going to just skip count by 8s to see how many times 8 goes into 39. 8, 16, 24, 32, can't go to 40. So I see that 8 goes into 39 4 times, and I'm going to subtract out the multiple of 32. So now I have 39 minus 32, which equals 7. The 7 is my remainder. So now, the quotient of 4 becomes my whole number. Do you remember what happens with my remainder? What does that become? I hope you said our new numerator, because that's exactly what it becomes. And then our denominator stays the same. It doesn't change. It was an 8 in 39/8, and look, it's an 8 over here in 4 and 7/8. Okay, I'm going to give you a few moments to write that down. Make sure you show work like this division step, because if you don't have the division step, you're pretty much missing the process. All right, our next problem is 25/3. Boys and girls, at some point, hopefully in the near future, you will be able to do these problems in your head. Right now, since it's our beginning stages, I'm walking us through the process where we show the division step. Okay, now we have 25/3. I hope we remember fractions as division, because this is really like saying 25 divided by 3. And that's exactly what I'm going to set up. I have 3 on the outside, 25 on the inside of my division bracket. And now I'm thinking, how many times does 3 go into 25? Or, which multiple of 3 is closest to 25, but it's not more? I'll skip count by 3s. 3, 6, 9, 12, 15, 18, 21, 24. So it goes in 8 times. That multiple would be 24. So I can subtract 25 minus 24, and I get a remainder of 1. All right. So my whole number is the quotient part. So I have an 8. And then the 1 becomes my new numerator. And who remembers what our denominator is? Hopefully you said it stayed the same, and so it's 3. So our answer would be 8 and 1/3. Go ahead and jot that down if you haven't yet. All right, our next problem is 49/11ths. Same situation. I want to set this up. It's really like saying, what is 49 divided by 11? Now, this may look a little confusing because you're like, oh my goodness, we've never worked with a two-digit divisor. Boys and girls, I can just skip count by 11s and see what's the closest multiple to 49 that's not greater. So let's do that. 11, 22, 33, 44. I can't say 55 because that is greater than 49. Therefore, 11 goes into 49 4 times. And I would subtract out 11 times 4, which is 44. That's our actual multiple. 49 minus 44 is actually 5. So this 5 becomes my remainder. And now I take the quotient without the remainder. That becomes my whole number. 4 and my remainder is my numerator, and my denominator stays the same. So my final answer is 4 and 5/11. Boys and girls, I'm going to give you a few moments to solve this one. I'll actually give you a whole minute to solve this one, and then I'll come back and share the correct answer with you so you can check it and see that you got the right answer. All right, go ahead and start. All right, boys and girls, I hope you were able to do your division steps and that you got 5 wholes because 3 goes into 16 5 times, and your remainder is your new numerator and your denominator stays the same. So you should have gotten 5 and 1/3. All right, if you needed to fix your problem, go ahead and fix it now. Press pause if you need to. Here's the next problem, 44/9. I'm going to give you a minute to solve, and then I'll come back and see how you did. All right. Hopefully when you did your division steps, you got 4 with a remainder of 8, which would mean that our answer is 4 and 8/9. Remember, the quotient part, not including the remainder, becomes your whole number. Your remainder becomes your new numerator, and your denominator stays the same. If you need to correct that, go ahead and take this time to do so. Feel free to pause the video. Let's move on to the next problem. You get another minute. All right. Hopefully, when you did your division steps, you got an answer of 5 with a remainder of 3, and therefore you have 5 and 3/4 as your final answer. If you didn't get that, look back and see what was your mistake. All right, let's look at the next problem. Go ahead and start that one on your own. I hope you all are getting these right. Make sure you use your resources too. If you still need to use your multiplication chart, feel free to use that. All right. Hopefully you got 5 with the remainder of 5, and therefore our answer is 5 and 5/6. Almost done. Let's look at this next problem. 31 halves. You may have to do a few more steps with your division this time, so make sure you give yourself plenty of space. All right, in this problem, you probably noticed that you had a 2-digit whole number. That was part of your mixed number. So 15 is our whole number and 1/2. Okay? So 30 halves would have just been 15 evenly, but it was 31 halves. All right, make sure that you got that down. If you need to pause the video, do so. The last problem that you have on your paper is 50/4. 50/4. I'm going to give you a moment to solve that. Again, you're probably going to need some space for this one. All right, so you should have gotten 12 with a remainder of 2. Yet again, we have a 2-digit whole number. So we have 12 and 2/4, and if I wanted to write it in simplest form, I would say 12 and 1/2. Either one of those works. So make sure you have this all written down. Just wanted to recap this lesson. Today we talked about converting improper fractions to mixed numbers, and there were pretty much 2 steps that you needed to do. The first thing you needed to do was set up a division problem. After you had divided the problem, your quotient was going, without the remainder, was going to be your new whole number, and then your remainder would be the numerator of your mixed number, and your denominator would stay the same. I hope you learned something. Hey, maybe you already knew this, and I hope it was just a great refresher. Until next time, take care.